order of a matrix. For example, if you have this matrix 1, 2, 3, 4, 5, 6. This is a row 1 and row 2. And this is column 1 and column 2 and column 3. There are 2 rows and 3 columns. Then the order of the matrix is 2 by 3. The first one is for rows. Next, square matrix is a matrix in which the number of columns and rows are equal. And in square matrix itself, there are 2 different types. The first one is diagonal matrix. Diagonal matrix. A diagonal matrix is a matrix in which, except the diagonal elements, means non-diagonal elements are all 0. For example, you can see here 1, 0, 0, 0, 2, 0, 0, 0, 3. All the non-diagonal elements are 0. Then it is diagonal matrix. The next comes your scalar matrix. Scalar matrix is a diagonal matrix in which the diagonal elements are same. That means, for example, if you are taking the 3 by 3 square matrix, the non-diagonal elements are 0 and diagonal elements are same. Suppose 2, 2, 2. The other non-diagonal elements are all 0. And one more type is there, that is unit matrix or identity matrix. Unit matrix or identity matrix. That is a matrix in which all the diagonal elements are 1 and the non-diagonal elements are 0. So these are the 3 types of matrices in square matrices. The next, transpose of a matrix. Transpose of a matrix is denoted like A transpose or A dash, like that. For example, A is the matrix 1, 2, 3, 4, 5, 6. Then what is A transpose? The rows becomes a column. That is, first row is this, that becomes a column, and the second row 4, 5, 6 becomes the second column. A is of order 2 by 3, then A transpose will be of order 3 by 2. Type of matrices, some type of square matrices. There are 2 types of square matrices. One is symmetric, another is skew symmetric. These are all square matrices. A symmetric matrix is a matrix where A transpose equal to A, and a skew symmetric is A transpose equal to minus A. For example, if you consider A equal to 2, minus 3, 4, here it is minus 3, 5, 5, then it is 4, 5, 7. From the observation itself, we can say it is symmetric matrix. What is the speciality is, see here, this is minus 3 and minus 3, diagonally opposite. Here it is 4, 4, 5, 5. So diagonally opposite matrices, when you consider, diagonally opposite means this is the diagonal one. Diagonally opposite elements must be same. Then it is symmetric matrix. It is not only that, when you take A transpose in this case, the first row becomes the first column. That is 2 minus 3, 4. That is the first. It is 2 minus 3, 4. Then minus 3, 5, 5, 4, 5, 7. If you interchange the rows and columns, you can see that this is same as A only. Okay, the next comes skew symmetric matrix. Skew symmetric matrix is a matrix whose definition is given as A transpose equal to minus A. And for any skew symmetric matrix, the diagonal elements are 0. For any skew symmetric matrix, the diagonal elements are 0. Suppose if you consider the non-diagonal elements like this, it is should be 2, 3 by 3 matrix I am talking about, and here it is 5. Yes. First one is the diagonal elements are 0. Second one is the diagonally opposite elements. You can see here diagonally opposite elements. One is 2, another is minus 2. Here diagonally opposite, one is 3, another is minus 3. Here minus 5, 5. Now, any matrix from, if you are given any matrix from there, A is any matrix, then A plus A transpose is always symmetric. And A minus A transpose is always skew symmetric. So by keeping this in mind, you can say that any matrix A can be written as sum of a symmetric and a skew symmetric matrix. The first one is the matrix which is symmetric. Second matrix is skew symmetric. The first one is A plus A transpose by 2. If a matrix is symmetric and you multiply with 1 by 2, it still remains symmetric only. Here it is A minus A transpose by 2. That is skew symmetric matrix. Now some properties of matrices transpose. Property is A transpose whole transpose equal to E. Second, A plus B transpose equal to A transpose plus B transpose. This is true for minus also. A plus or minus here becomes minus. Then the third property is very important. That is AB whole transpose equal to, it is B transpose into A transpose. You can just see that A into B is the order in which A and B are multiplied. Here when you take the transpose of B comes first into the transpose of A. This is very, very important. The first one is missing. Second one, the number of all possible matrices of order 3 by 3 will with each entry 0 or 1 is. So it's a 3 by 3 matrix. So in a 3 by 3 matrix there are 9 entries. These 9 entries with each entry as 0 or 1. That means here in this place you can have 0 or 1, and for this place also you can have 0 or 1, 0 or 1. So in how many places are there is? There are 9 places like that, and if you can consider in each place 0, 1, 0, 1, 0, 1. So in each place can be filled up in 2 ways. So the total number of 3 by 3 entries, that is the total number of entries in the 9 places, will give the total number of different matrices with either 0 or 1 as entry. It is 9 places. Each place will have 2 entries. So it will be 2 into 2 into 2 into 2, 9 times. So it is 2 to the power 9. So this is the answer. The second one, a matrix A is both symmetric and skew symmetric, then symmetric matrix, skew symmetric matrix, just now I have told, for any skew symmetric matrix, for example, if you consider a 3 by 3 matrix, 1, 2, 3, 4, 5, 6, 7, 8, 9 entries are there, and how the entries will come. When it is skew symmetric, these diagonal elements must be 0. When it is symmetric, suppose here it is A and B. When it is symmetric, A must be B. When it is skew symmetric, A must be minus B. So A equal to B and A equal to minus B. These two together will satisfy only if A and B are 0. At the same time, they are equal. At the same time, one is opposite sign of the other. That means A and B are equal as well as A and B are of opposite sign. This is possible when A and B are 0. Similarly, suppose you consider CD here. That also the same condition. In order to make this matrix symmetric, you should write C equal to D. And in order to make this is skew symmetric, you must write C equal to minus D. This is possible when C equal to D equal to 0. That means all these entries are zeros. So the answer is A is a square matrix and a zero matrix. A is a square matrix and a zero matrix, because symmetric and skew symmetric are always defined for square matrices. Question number 4. If A equal to this matrix, B equal to this, then the value of A for which A square equal to B. So matrix multiplication I have to do. A square means A into A. A into A means you can write here alpha 0, 1, 1. That into again alpha 0, 1, 1. How to multiply this is, from the first matrix you always consider row, and from the second you will always consider columns. The corresponding elements will multiply. That means alpha into alpha, alpha square, plus 0 into 1, that is 0 only. Again the first row you will multiply with the second column. So alpha into 0, 0, plus 0 into 1, 0. Now next we will consider the second row. Second row you will multiply with the first column here. So 1 into alpha plus 1 into 1. So we'll get alpha plus 1. 1 into 0 plus 1 into 1. That is 1. So you are getting here alpha square. You are getting alpha square 0. Alpha plus 1, 1. This is equal to B. Equal to B means two matrices are equal if their orders are same and the corresponding elements are equal. Then what is the value of this alpha? I hope it is alpha only. So alpha square equal to 1. So that means what? Alpha square equal to 1. Alpha square, here it is equal to 1. And one more thing, alpha plus 1 equal to 5. Alpha plus 1 equal to 5. So both together there is no alpha possible. Alpha square equal to 1 means alpha can be plus or minus 1. But alpha plus, if you are putting that value in the second equation, doesn't satisfy. So the answer is not possible to find. The next one is C is a skew symmetric matrix of order n. X is a column matrix of order n by 1. Then X transpose dash written means it is transpose. Cx is what type of matrix? You have to now see the order only. So now what it is? C is a skew symmetric matrix of order n. X is a column matrix of order n by 1. So x dash means it is a transpose. So the order of uh, x dash, x is a column matrix of order 1 means x dash का order क्या आएगा? 1 by n. And C is a symmetric matrix. That means it is a column matrix. So I'm just going to the next board. We have to find out x dash Cx. What was given is C is a symmetric matrix. That means it is a square matrix. C is a square matrix. This X is of order 1 by n. You can see X is of order, n by 1. It is a column matrix. So now X is a column matrix. C is symmetric matrix. X dash is of order 1 by n. Then into C. C is a symmetric matrix. When the matrix multiplication is there, it should be n by n. So that this n and this n will get cancel and you will get after this x dash C का order क्या आएगा? X dash C का order will be 1 by n. And into then again one x is there. This x is of order n by 1. So First we multiply these two, x dash c. X dash c of order 1 by n. C is of order n by n. It must be of order n by n because C is a symmetric matrix, so it is square matrix. Then x dash C is ka order, that will be 1 by n. Here you can see that it is, this n will get absorbed and this will be of order 1 by n. So I have written here 1 by n. Then again you are multiplying with x. X is of order n by n. Then what will come next? It will be, its product will be of order 1 by 1. So it is 1 by 1. What is the other thing? Square matrix may be given 1 by 1. The full answers are not given. Okay. So accordingly you can go next. Question number 8. A is given. A into a matrix is given. Then what is A? What you have to do here, children, instead of finding out A, you just take one. By seeing the order of the matrix, you can decide very fast. The second matrix is of order 2 by 3. And this is of order 3 by 3. Then what must be the order of A? So order of A must be, this final product is 3 by 3 means you will be getting here 3 by this 2. This is of order 3 by 2. So that this 2 get absorbed and you will get 3 by 3 matrix. Now A must be of order, you have concluded that A must be of order 3 by 2. Then only A into this matrix is defined. A must be of order 3 by 2. 3 rows and 2 columns. So there are two options. This one 3 rows, this one 3 rows. Now you multiply and see whether you are getting this answer correctly or not. That will be the easy way of finding out. Okay, so first I am taking this matrix option C. I am multiplying with this 1 minus 2 minus 5 3 4 0. When I multiply, whether I am getting this right side matrix or not. 2 into 2 minus 1 with 1 3. So it is 2 minus 3. 2 minus 3 minus 1 is correct. Then 2 minus 1 into the next one is this minus 2 1. So 2 into minus 2, it is minus 4 minus 4. So this is also correct. Then 2 into minus 5, third column I am multiplying. So we'll get minus 10. So this is correct. Then 1 0 with 1 3 I am multiplying. I am getting 1 correct. 1 0 with minus 2 4. So it is minus 2 I am getting correct. Then 1 0 with, so that means what? This B is wrong. So your answer is C. No need of doing for the whole thing. Okay. Next question number 10. A equal to this, B equal to this. Then the element of second column and third row of AB is second column and third row. Second column and third row means that matrix, that element will be, first you have to mention the row. So it is third row, second column element. So A32 you have to find out. To find out A32 from this product matrix AB, how will you get A32 from the product matrix? First matrix ka third row you will multiply with the second column of the second matrix. First matrix ka third row you will multiply with the second column. So what answer you will get? It is 5 into 2, that is 10, plus minus 1 into minus 5, that is 5, plus 6 into minus 8, so minus 48. How much it is coming is minus 33. The next one, question number 12. If A is given is a symmetric matrix, then the value of X is, when A is symmetric, you should know that A transpose is equal to A. That is the easy way to do. A transpose equal to A. So this is equal to A transpose, we can write here. So it is 3x plus 1 and 2x plus 3, x plus 2. The first row becomes the first column, the second row becomes the second column. Now these two are equal. A equal to A transpose. So 3 equal to 3, and you will get what? X plus 1 equal to 2x plus 3. So from there what you will get? X equal to minus 2. And the other one you can check also. X plus 1 equal to x plus 3x. So x equal to minus 2, that is D is the answer. Choose the correct statement. Every identity matrix is a scalar matrix. Every scalar matrix is an identity matrix. Each diagonal matrix is an identity matrix. A square matrix with all elements 1 is an identity matrix. So what is correct? Every identity matrix is a scalar matrix. I have explained the starting of the class. If A is next question number 14. If A is a square matrix such that A square equal to A, then I plus A whole square minus 3A is. So what you will do? Just like your algebraic identity, you can proceed here. I plus A whole square means it is A square, A plus B whole square जैसे चलना है. That is I square plus 2 into I into A plus A square minus 3A. Now I into A is A only. Identity matrix into any matrix is A only. And I square is always I. So it is plus 2A. And what you will do for this A square? It is given that A square equal to A. So this A square you can write it as A. Then minus 3A. So you can see that 2A plus A, 3A minus 3A get cancelled and you will get finally I. So I is the answer. Question number 15. The values of x, y, z, if two matrices are equal, you can see that both the matrices are column matrices. So if two matrices are equal, the corresponding elements are equal. So what you will do, you need not have to solve it. One of this you take and check it. Odd man out, you can throw it. X equal to 2, x equal to 3. X and y, the first one you check. Whether x plus z equal to 5. That you see when x plus z equal to 5. Because this one you're comparing x plus z. First one x plus z is not 5, so this cannot be. Second one x plus z is 5. Then you see y plus z. Y plus z is 7. X plus z is 5. Here also it is correct. X plus z equal to 5. Here it is not correct. X plus z equal to 5. It is correct. So these two में कोई एक होगा. So now you will check y plus z equal to 7 in which? Y plus z, here it is 7. Y plus z, here it is 6. So this is not possible. So this is not possible. So your answer will be B. So no need of solving it. Okay. Question number 16. Matrix A is given is a square root of, if a matrix A is a square root of a 2 by 2 identity matrix, then the relation between A and B is. So let us leave that question. Suppose 3 by 3, question number 17, children. Suppose 3 by 3 matrix A equal to Aij, whose elements are given by Aij equal to I square minus J square. Then A32. A32 means you have to put I equal to 3 and J equal to 2. So we will get A32. I equal to 3 and J equal to 2. So we'll get I equal to 2 means here you will substitute. So 3 square minus 2 square. That is 9 minus 4. So the answer is 5.